All right, people, here we go. Chapter 5 is all about linear functions. Lesson 5.1 talks about rate of change and slope. So after this lesson, I should be able to find the rates of change from tables and find the slope. All right, here we go. Stop. Again, please make sure your volume is on. You need to hear it as well as see it. And please don't copy the notes. Follow along. The rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. The rate of change is always equal to the change in your dependent variable over the change of your independent variable. So you can see here it is a ratio, change in your dependent variable over change in your independent variable. So what we see is that we can use ratios to show a relationship between changing quantities such as vertical and horizontal change. So when I look at a graph, how much does the graph go up or down compared to how much it changes side to side? And I'll use a ratio to explain that. All right, the table shows the distance the band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? All right, so let's look at our table here. We got time over here in minutes, and we got distance over here in feet. So let's think. Which one is the dependent variable? The dependent variable. Well, that's always my y column, my outputs. The distance I go depends on how long I walk. The shorter I walk, the less I can go. So obviously my distance depends on the time. All right? So remember, your rate of change is your change in your dependent variable over the change in your independent variable. So since the distance the marching band travels depends on how long they've been marching, the distance is the dependent variable and the time is the independent variable. All right, to calculate that rate of change, let's use two of the points. So if we're going to do the dependent variable over independent variable, so it's a change in the distance over the change in the time for this situation. All right, so let's look at two of those points, 1, 260 and 2, 520. So I'm going to find the change in the distance on the top of my fraction and the change in the time on the bottom. So I'm just going to take 520 minus 260. So I took this one minus that one. So on the bottom I have to make sure to do 2 minus 1. All right. You could do it the other way and you'd wind up with two negative numbers. When you divide, you still get a positive. But normally we try to go bigger minus smaller just to make things easier. 520 minus 260 is 260 over 1. All right. Let's take a look at a couple different points. So I'm going to use the 2, 520 and the 3, 780. Same idea. Change in distance would be 780 minus 520 on the top, and the change in the time would be 3 minus 2 on the bottom. Well, 780 minus 520 is just 260, and 3 minus 2 is just 1. So it looks like it's staying the same. All right, let's take a look at the last 3 points. So the rate of change would be 1040 minus 780. On the top, that would be my distance change, and then 4 minus 3 on the bottom, which would be 260 over 1. So you can see it stayed the same each time. So the rate of change is constant, and it's equal to 260 feet over 1 minute. Because remember, your distance was in feet and your time was in minutes. So 260 feet over 1 minute. So what does that mean? It represents the distance that the marching band marches in 1 minute. They go 260 feet every 1 minute. Notice it stayed the same. So this would be a linear relationship. It would be a linear function. All right. The graphs of the ordered pairs, distance and time, in problem 1 lie on a line. They were all in a line. The relationship between time and distance is linear. Okay, that makes sense. When data are linear, the rate of change is constant. So any linear functions, you're always going to have a constant rate of change. When you graph your points, they're always going to be in a line. So these are the points from the chart, and you would see that, notice they line up nice and easy in a perfect line because the rate of change is constant. Notice also that the rate of change found in problem 1, that problem about the marching band, is just the ratio of the vertical change, how much up and down, or the rise, to the horizontal change, or the run, between any 2 points on the line. The rate of change is also called the slope of the line. All right, so really kind of when you use just points and stuff, then you're talking about rate of change. And when you look at a picture on a graph, then they kind of call it the slope when you're dealing with the line. All right, but those two terms are pretty much interchangeable. So how much I went up? I went up 260. I went over 1. So notice it's the change from any point to the next point. Up 260 over 1. All right, now look at the scale here. So that'll help you with your 1. Up 260 over 1. Up 260 over 1. Up 260 over 1. Okay? That's just your slope of the line. All right, so there's a lot of ways to think about slope. We already talked about the change in the dependent variable over the change in the independent variable. We can also call that the rise over the run. Maybe you've heard that before. I always think of it as the vertical change over the horizontal change, how much up and down compared to how much over. And then also you can think of it as your change in your y's over your change in your x's. Okay? Notice your dependence are your y's, your independence are your x's. So all of these ideas really say the same thing. All right, what's the slope of the line? So however you think about it in terms of one of these four things, or if you have a different way to think about it, that's fine too. I always kind of think about it as vertical change over horizontal change, or rise over run. So from this point to this point, because I read the line like I read a book, from left to right, this line is going up from left to right. So from this point to that point, I would go up 2 and over 3. So the slope would just be 2 over 3. Don't change it into a decimal. Just leave it right like that, fraction. If you could simplify it, you would. But 2 over 3, you cannot. So we just leave it. All right, easy enough. All right, here's another line. Now notice this line goes down from left to right. From the left spot of the graph down to the right. So from this point to that point, I got to go down and then over. All right, so it's still vertical change over horizontal change. So it goes down 4, and I'm just counting the blocks. 1, 2, 3, 4, and then over 5. All right, so negative 4 over 5, down negative. All right, so notice lines that go down from left to right have negative slopes. The previous example had a positive slope. This line goes up from left to right. From left to right, the line goes up. So it has a positive slope. From this left point to that right point, I will go up 2 and over 5. And I'm just counting the blocks. 1, 2, 3, 4, 5. All right, so 2 over 5. If you could reduce it, you would, but you can't. So just leave it like that. All right, normally we leave slope as a fraction. All right, you can use any 2 points on a line to find its slope. And I use subscripts to distinguish between the 2 points. So those subscripts mean these little numbers on the bottom here. All right, they're not squareds because they're on the bottom. Squareds would be on the top. So please don't get that confused. All you're trying to do is identify the points. So you just pick one of the points and you name his coordinates x1 and y1. Find another point, name his coordinates x2 and y2. It doesn't matter. You could call this one x2 and y2 and this one x1 and y1. It's just trying to keep the x's with the y partner together. Okay, so that's all that's trying to do. To find the slope, we use the slope formula. All right, so if they gave me 2 points, not on a graph, I would use the slope formula. All right, remember that a line that goes up from left to right, like that, up from left to right, please draw a little sketch of that on your paper, has a positive slope. And a line that goes down from left to right, like that, please draw a picture of that, has a negative slope. All right, if you can remember that, from left to right, if you trace it with your finger from the left side to the right side, from the left side to the right side, and you can remember up has a positive slope and down has a negative slope, that'll take care of a lot of problems that you might have down the road. All right, so slope formula. It's still the change in the y's over the change in the x's. So change, I got to subtract. So I just take my y number, subtract the other y number. I take my x number, subtract the other x number. Now the reason you have these little numbers here is because if you use this y first, if you use B's y first, you have to use his x first on the bottom. You could use A's y first, but then you just have to use A's x first on the bottom. That's all that those numbers mean. Okay? So it's just trying to keep the point together. So notice this is 1 point. In this case, it's point B. And this is 1 point, it's point A. You just can't use this x number on the bottom first and then that y number on the top first. You just can't do that. So you can't mix it. All right? So use the slope formula to find the slope of the line. So it's the change in the y's over the change in the x's. There's my slope formula. Subtract the y's on the top, subtract the x's on the bottom. Looks like that. So I always just take it and just break it into a little list. And say, okay, there's x1, there's y1. There's x2, there's y2. All right, x, y, x, y. x1, y1. x2, y2. All right? You could call this one x1 and y1 if you want, and x2 and y2 if you want. It doesn't matter as long as if he's x1, his partner's y1. If he's x1, then his partner's y1. Okay? So it looks like that to me. I just go right in order, no big deal. And then I just plug them into the formula. So y2 would be negative 2 minus 0 over x2, 3, minus negative 1. Now you got to be careful because you might have some minus negatives come up in some of these problems because the formula says to subtract. So I might be subtracting a negative number. But that's okay. We can handle that. So negative 2 minus 0 is just negative 2. 3 minus negative 1 is the same as 3 plus 1. So that would be negative 2 over 4. I'd like to reduce if I can. Negative 2 over 4 just becomes negative 1 over 2. All right. We're better off leaving fractions instead of decimals. Okay. So let's leave it as a fraction, negative 1 over 2. All right. Nice. A couple more examples of that. It's still slope formula. Change in y's over change in x's. And again, I just list them out. x1, y1, x2, y2. Bang. Dunzo. Throw them into the formula. Here's my y2. Here's my y1 on the top. Here's my x2. Here's my x1 on the bottom. Bang. And I get negative 5 over 2. I can't reduce that. I leave it. Do not turn it into a mixed number. Negative 5 over 2 would be the best slope you can write. All right, here's C. Negative 3, 2, and 2, 2. All right. So let's take a look. Changing the y's over to changing the x's. So negative 3, x1, 2, y1. 2, x2, 2, y2. Okay, so there we go. So throw them into the formula. So I'd have 2 minus 2 over 2 minus negative 3. Again, you got that minus negative, so just be careful. Well, 2 minus 2 is 0. 2 plus 3 would be 5. So you'd have 0 over 5. Well, 0 over anything, as long as that's not a 0. 0 divided by any number is just 0. All right? So that's a funky little thing. Whenever I have a horizontal line, notice these are the points. I plotted the points on this picture here. I wound up with a horizontal line, slope 0. So up from left to right, positive slope. Down from left to right, negative slope. Horizontal line, 0 slope. All right, here's a vertical line. So let's see what happens with this. So I have negative 2, and I have negative 2, 1. I drew the picture here. All right, but I'm going to do it with slope formula to see what happens. So negative 2, and then negative 2, 1. x1, y1, x2, y2. Bang. Throw them in. So y2 minus y1. Again, minus negatives, just be careful. Negative 2 minus negative 2, and just throw them in like that, and you'll be okay. Simplify the top would be 1 plus 2 over, well, negative 2 plus 2 would be 0 on the bottom. So you'd have 3 over 0. Well, I remember in 3rd grade, my teacher told me I can never have a 0 on the bottom of a fraction, or else that became undefined. So whenever you have a 0 on the bottom, it's an undefined slope. 0 on the top is okay, it's just 0. But 0 on the bottom is undefined. All right? So, a line with a positive slope goes up from left to right. A line with a negative slope goes down from left to right. A line with a slope of 0 is horizontal. And a line with an undefined slope is vertical. So if you keep those 4 ideas in mind, you're going to be just fine. Great. So I got slope formula. I got finding the slope, changing y over changing x, rise over run, whatever you want to call it. And that's it for 5-1, my friends. I'll see you next time. Peace.